Hello, everyone, and welcome. Thank you all for joining us today for this live stream event. My name is Adbena, and I'm the Program Manager of the Microsoft Reactor San Francisco. I will be sharing session resources with you in the chat, but before we begin, I would like to quickly review two items with you: our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link in the chat for our YouTube channel, and if you have not been on the stream live before on YouTube, please know that you must create an account on YouTube in order to access and interact in the chat. You can set that up right now, and if you're unable to use the chat but have questions, feel free to reach out to us through the social media or meetup. Which brings us to today's session, Exploring Distributed Tracing in .NET, the Reactor Code Lab. This session will run for approximately 60 minutes. I'm going to bring in our speaker for today, Sam. They are a regional cloud advocate in Microsoft. Hi, Sam.
Hello, thank you so much, and hello everybody. I am Sam Wronski. I'm a regional cloud advocate here at Microsoft. My job is to help empower all of you to build awesome things on top of Microsoft's platforms and software. So what we're doing today is taking a look at observability in .NET, and specifically looking at how to do distributed tracing in .NET. So what tracing is taking a system or a signal and tracing that signal through a system. So think about sending some request to some website. You might have a series of maybe print statements throughout your application that are going to say, here's what's happening here. Maybe that typical debugging of here and made it here or whatever inside of your chat or inside of your program. What you can do here is set up a distributed system that will actually track signals throughout your entire architecture. So as you're sending a signal to your web service, you'll be able to see how long that signal took interacting with a specific service and how far it got through your system and how it got there, so that you can actually trace that back and see if everything's behaving as you expect it to. This also gives you a way to identify what's causing slowdowns in your traffic. If you have a distributed service and it has maybe 20 different things going on in it, and you want to figure out why does this take 2 seconds to respond to a user, that's really hard if the only information you have is the start and end of that signal. You just know somewhere inside of those 20 services, something is taking a long time. If you're trying to do this in a distributed tracing sort of way, you'll be able to see exactly how long every part of that process took and be able to actually trace that back. So this is something that I'm still learning. If you're new to the Reactor Code Lab, the premise behind this is we're going to take things that I'm trying to learn, maybe for a project that I'm working on, or just because I was reading about it, and we're going to try to learn that together. So that's what we're doing today. I have created the most bare bones of .NET applications. It is one line. It looks like this, and we're going to try to add distributed tracing to this, see what it gives us, and how maybe we can interact with other services to actually look at that trace and actually derive some information from that. Also take a little bit more information about open telemetry, which we're actually going to be using throughout this project to keep track of everything that's going on. And this provides things that aren't just distributed tracing, but also provides things like a logger and ways to actually track your system throughout. So we're going to take a look at that too. But yeah, this is where we're at. If you don't know how to get to this point, .NET New Console. And there you go. This is just using the .NET 6 or the C#6 template. So there we go. And so we get that. And now we end up here. So this is the distributed tracing documentation. We're going to just dive in and see what we can figure out. I'm going to be jumping around a little bit because I have done some of this before. So we'll get as far as we can. there are different options when you're thinking about how to do tracing inside of your application. You can look at OpenTelemetry, which is a neutral platform tracing and telemetry library. This supports a whole broad set of analytics and telemetry providers. And so you can interface with all those different things. There's also importers for things like application insights, if that's what you're already building your application on. So you can actually do that. But in this case, we're just going to stick with OpenTelemetry. If you do want, you can use things like application insights as a default thing. And that will come with some extra built-in things because it's more focused and targeted for a specific platform. It has some things already built in that you might have to do yourself with OpenTelemetry, just because OpenTelemetry is more open, it's more broad. So different options for you depending on what you're doing. I'm trying to figure out and learn more about OpenTelemetry, so that's where we're going to stick. So let's take a look at that. First off, I should mention OpenTelemetry is an open source project, so you can go and browse this. There's different providers, and this doesn't just mean that there's a provider for .NET. If you're building a microservice platform, whatever language you're using probably has support for an OpenTelemetry provider. So you can integrate that, whether that's Python or Java or Go or .NET. So you can start integrating all of those and then getting all of your telemetry stuff into a uniform bundle that you can then deal with in your platform. So that's that. We're not going to spend too much time looking at this as itself. We're just going to look more at the application side and how we can actually use this to divine things about our application. So that's that. Let's go and dive into this. I have been just quickly tinkering with some things just to see if I needed to do anything or set anything up. So that's why it looks like I visited some of these links, but that's where we're going to go. So let's go and get started. So we can take a look at the concepts. I think we're going to quickly step through here because there's not too much that we want to do here. The most important thing is that everything is tracked using activities, which is a set of just an action that you're performing. So think of an activity like invoking a web request or something like that. That's when you will start that activity and it will trace the duration of whatever activity you're performing. And so you can embed activities inside of activities. And this gives you a way to kind of just see what happens when you say, this was invoked. What does that mean? So there's that. And then we can do instrumentation. And I don't know. There we go. So this is sort of where we're going to actually start coding this thing. So let's add the diagnostic packages so we can actually start working with this. And some of our OpenTelemetry stuff. So can add this. This will add the system diagnostic package, which is a broader, I believe it's the package for actually managing diagnostics across different things. So this means not just OpenTelemetry, but I believe it also works with application insights. Just sort of a broad ability to do those kind of things. Not a package that I'm super familiar with, so I'm not going to say much more. And then we're going to add our OpenTelemetry and our OpenTelemetry exporter for the console. So the way this works is we're going to set up something that's going to actually track our telemetry data. In this case, we're going to use OpenTelemetry to do that. But then we're also going to have to export it somewhere. So we're going to use a console exporter in this example, just to print this stuff out to our console. And then we can go back later. Hopefully we'll get through this all super quick. And then we can get to this and start trying to swap out our exporter and maybe send it to some other service, whether that is out to application insights on Azure or to some other open source thing like Zipkin or what's the other one? Jaeger. So if you're thinking about sending it to different places, that exporter is how you would do that. That is not something I've played with at all. So I don't actually know how to configure or do anything with that. So I'm kind of hoping we'll get to that point in this next hour. If you are curious or maybe haven't played with distributed tracing, feel free to ask questions in the chat, and I would be happy to kind of go on a detour and learn together. Otherwise, we're just going to kind of walk through this and then go on the detours that I want to. So there we go. I'm going to go and add this telemetry package right here. Can I do both of those? That seems fine. There we go. All right, so now we can see we added 3 different packages. These are the 3 that we added through this whole thing. We have our OpenTelemetry exporter, and our diagnostic source. So what we are going to need to do is configure that exporter so that we can actually export these logs somewhere. That's going to be something that we have to do. Otherwise, we can collect this information, but we're not actually telling it to go anywhere. The reason you need an exporter, and this isn't like magically figured out for you, is because there's lots of different ways and configurations that you might want to do this. Writing things out to your logs is great for like a personal just trying to figure that out. But if you actually want to use this in your production applications, you probably want this going to some telemetry dashboard or some place that is actually collecting these information and figuring out, is this still in line with our SLOs for the response time for this endpoint? And you can't really do that through the console, at least not easily. You'd have to write some custom scrapers. And so having an exporter that can take the rich data and export it directly to one of those services can be more useful. So that's that. And so I think we're good there. Let's actually go and add some of this now. So what we're going to do now, this demo is not using the flat application. So my stuff is going to look slightly different. That should be fine. There shouldn't be any like major things here. This is just, it has a main method. That's the main difference. For me, that gets generated behind the scenes. So let's go and take a look. One of the things that I like to do when I'm learning something is actually step through it like one after another. So what's happening here is it looks like we have a trace provider. Let's do this and then see where this gets us. So if we go into our program, again, this is the console template, the new console template. If you're maybe focusing more on like ASP.NET or something, and you haven't seen one of these before, the main method is now inferred inside of a single file project like this. So we're assuming that this is the inside of our main method. So we can still do usings and we can do all of that normal stuff. We can declare functions. It's just going to execute this like it's our top level function. So do this, and now we need to import our thing. And do I not have? All right, gonna do a quick detour. Let's just open Visual Studio because my IntelliSense seems to be figuring out these packages still. Visual Studio already have that done for me. So I think we're just gonna swap over there. It should be relatively quick here. Sorry. All right. Too many projects. Let's go here and go into our project. So development. And then I'm just going to go and find the project file that I just created for this and open it that way. Not dependency injection. Let's go into distributed tracing. And so this should just quickly get us to the same point. We're just going to be doing this in Visual Studio now instead of Visual Studio Code. Hopefully that will give us IntelliSense. When I'm first learning something, I lean really heavily on the tools like IntelliSense because that's how you learn things. You get all these suggestions about here's what you can do. And then the question is, how do you figure out what you should do? And so that's why I'm kind of trying to do this because we're still trying to figure this out. And so the best thing that I can do is get that hint and kind of go from there. In this case, we have the code sample. We know what we need to do already. So I could just copy it in. I don't like doing that because I find when I just copy code, I don't think about what it does. And then I don't know how to actually take that and transform it or use it in the stuff that I'm actually doing, or why each of those specific lines are there in the first place. And so one of the things that I can get by doing this is actually get some hints here. So let's apply this. I'll make the screen bigger in just a sec. How's that? That's better. So here is this. So let's continue this. Add instrumentation. What is it doing now? So we have a whole bunch of things we can do. We can add a source. I don't know what that is, or add instrumentation, or a legacy source. I imagine what are they doing? So let's go, and it looks like they have a source that is coming from this. I'm going to need to make this slightly smaller just so I can see it. Set a resource builder. Okay, so it's setting a resource builder, which I think is setting up the service that is actually holding or owning whatever is being done here. And it looks like we have a source that we're adding, which is going to be where this is coming from. I believe that is probably going to reference what application you're actually doing that. So that would probably be your application name. In this case, it looks like they've used the namespace. And then add the console exporter, which is that package that we added. So you would swap this out if you needed a different type of exporter. If you're maybe sending this to some other service, you would swap that line out, and then we'd build this. So this is some sort of builder that we're doing to get this tracer provider. So that's how that's working. Let's go and see if we can actually duplicate that. So we have this. Let's go down here and do a set resource builder. And then we have a resource builder dot create default. So that's creating the default one. And then we want to add a service. Add service information to a resource builder. What is a resource builder? From which the resource builder, well, let's see if we can go. I don't want to go this deep. I'm sorry. Let's see here. Let's not do that. That was asking me if I wanted to decompile the source and try to do that. Don't really want to do that. So we're going to ignore as much of that as we can. It's still trying to do some things. That's fine. So what is this? Contains methods for building resource instances. Okay. So it looks like this is an open telemetry thing. And there's a bunch of links out to GitHub here. I'm not going to dive too deep into this documentation where that isn't really what I want to do. But if you want, this is how I would find this information. And you can go and read up on this yourself. For what we're trying to do, we're trying to kind of get to the point where we can test a distributed system. And we kind of have a limited time, so we're going to skip over this part. But that's how you can find that, is you can either look at the documentation for whatever it is, or you can go and check out the GitHub page for what you're using. In this case, we're using the OpenTelemetry packages. So you can just go and look at the OpenTelemetry documentation for that. So in this case, we added a service. So let's just call this service. Should be fine, right? And again, what this service is and how you should use it is going to be defined inside of this documentation. And then we're going to make our code look slightly less bad, just because, there we go. Then we want to add a source. And the name of the source is us. So this is going to be our Reactor code lab dot tracing sample. And so what I'm expecting is to see this listed somewhere in what we're doing. My expectation with this is that we'll have some sort of unique ID attached to an activity that we create in order to track this. And so we can use that activity to kind of figure out what's going on. We have this dynamic source that we can use as a way to actually figure out what's going on. And then this is going to tell us what application we're in and should label it inside of our traces so we know where we are. And that way we know I need to go and look at this application if this is having issues. Another thing that you can get from this is if your code is throwing an exception, instead of just getting a 400 back somewhere and trying to go through your logs to figure out what's going on, hopefully you should be able to see where that exception happened and what point along the execution it happened. So that's also something I'm kind of looking to see here. And then I think we did one more thing, right? We added the exporter. So add the console exporter, and then we built it. Cool. So add our console exporter. Again, we can change this later if we want to. We just need to actually have another exporter. And I imagine this is also where you would import things like the settings for that exporter. If you're exporting it to another service, you're going to need connection details to get to that service so you know how to export it. And then we can build this. And there we go. So that's that. Now the next thing is it looks like they're firing off a do work thing, which is going to go and do some work, and then that's it. So let's go and just copy this. You don't. I don't think it's going to be that useful to see me write some basic async functions, so I'm just going to directly copy them, and we can build on this later. So there is our do work tasks. So we can do some work, and then console write line. Job's done. There we go. And that should do that. Do some work needs a set of arguments that we don't use. Okay. We can do that. So foo and 100. Why not? And there we go. Again, this should work. And then we just need to await this. One of the fancy things with these top level functions is if you add an async function, like an await here, that main method now becomes asynchronous too. I used that code and my computer got a lot of damage. What could I do? You shouldn't. So this shouldn't do any of that. There's probably something else going on if that's actually something that happened. So I would check that. Yeah, don't know what to say, but this shouldn't do any of that. So we have this. Let's do job's done. That's going to run this. Run 2 async tasks. All these are doing is just waiting. So one task is going to wait for 500 milliseconds, and then another one's going to wait 1,000 milliseconds. These won't be exact. That isn't how these async functions work. If you're using like sleep to wait for a minute or something, and you define the specific amount of time, that isn't the actual time it's going to wait. It's going to wait for about that. So keep that in mind. We won't see exactly 500 or exactly 1,000, but that's what that's doing. So I think we can just run this and see what happens. I don't think we're expecting to see anything here. And let me see here. I would like a console terminal. There we go. So while that starts up, I think I can make it bigger. I cannot. Let me just see if I can quickly. That is not going to make it bigger. Oh well, we can do this in another way. Let's do that. See if that works. Nope, that didn't work. Sorry. Okay, interesting. Will it work if I just run it with just the path? Nope. All right, cool. Oh, there it is. Perfect. All right. Got it. Okay, so if you type WT, that's for the Windows terminal. That's what that's doing there. And so that's doing is sending a command to open another tab in the Windows terminal. I was trying to pass a specific path. Looks like if you just run it at that location, it will just open up. Another fun tip, if you do that in Explorer, it will also open up, like if you type WT, it will open up at the Windows terminal at that thing. So let's go and run this and do .NET run. Make this a little bigger. All right, so job's done. So that's our tracing run. But we didn't actually trace anything. We didn't actually do any of the work that we have been trying to set up this entire time. We didn't get any traces coming back. Nothing actually worked. So that's the next step. We need to actually track what's going on here. So that's where this diagnostic library comes in, is we can actually create activities. And then these open telemetry libraries plug into that. And so what this means is that you can swap that out with some other library, and all of your actual tracing stuff is already done. The really cool thing with this is that it means that if you're building a library or you're building something to share with people, you can build on top of this diagnostic library and use all the stuff there. And then as people introduce their own tracing subsystems and start injecting those into their code, it will still work. So you can still use and take advantage of a lot of this stuff by doing that. So that's one of the really cool things here. So what's going on here? We're creating an activity source. Activity sources provide APIs to create and start activities. All right, so this is going to be something that we're actually going to use to grab our activity source or our activities from. So this seems like a builder function. It seems like we're creating a factory here. So that's going to be something that we're going to use to actually generate new activities that we can use throughout our application. And what it's going to do is, let's import this, is give us a way to actually grab this information. So I think what I want to do here, we don't need this to be static. It's already at the top level. So I think we should be good here. So what we have is we have an activity source that's going to give us this information, and we have a name and a version. I believe if we jump back to this documentation, the name here is sample distributed tracing. If we go up, that's the same as the namespace and the same as the source here. So I'm going to probably pull that out into some sort of constant, and we will use that instead. So we'll just call this our source name work. And we'll call this Reactor Code Lab tracing sample. And actually quote that so we get a string, because otherwise that's really not going to work. There we go. Cool. Constant string. That's how this works. So we created this source name, and now I'm going to swap this out for both of these. So we can get this here. Ideally not inside of quotes. There we go. And we'll do that here as well. This way, everything is the same. So we're always using the same name across this solution. This will just help align everything. The other thing we have is this version. This is the version of your application. So in this case, it's 1.0. We could also change this and maybe align it to something like a Git SHA or something like that, so you actually know what version of the actual code this is. And that way, if you start seeing issues with something, you can actually just pull that specific Git SHA and use that to actually track down whatever the issue is. So that's what that can be for. We're going to leave it there just because this is a sample application. We shouldn't see too much anyway. So we're just looking for this number to figure out where that actually ends up in our trace. And then here, we're going to do some work. Job's done. Cool. And so we just need to actually add our activities. So if we go back down here, we have our activity source, and now we just need to do our activity. So in this case, the way that's done is by wrapping things inside of these using statements. I'm going to change this a little bit, I think, and use a top-level using statement. And what this does is instead of increasing your cyclomatic complexity by adding 2 more curly brackets then in a tab indent, it will just work in the scope of whatever you're doing. So here, when we're doing do some work, we have this using activity. We can leave that like this. And so instead of having it inside of a block and removing that when the block exits, this will work over the scope of the function. So from when we create this using to the end of that, it will stop. So this gives us a way to kind of track this function more easily. Then source is from up there. Why doesn't it like this? Static local function. Oh, because this isn't static. But I don't think I can make this static, can I? Yeah. There we go. And those don't need to be static anyway, because we're invoking all of this from one program. So there's our source. We're going to start the activity, do some work. I'm going to up it out with a name of and do some work. What this does is replace your strings with the actual reference to the function. This is helpful because this turns a misspelling or something like that into a compile error. So if I do some work or just do work, this no longer compiles because there is no function called do work. So this makes sure that these names align correctly and they actually match with something, especially when you're refactoring across a large code base. I found this can be really helpful because you can miss just strings that don't quite get refactored, especially if you're trying to like do it with regex. You might accidentally include things that you didn't mean to, and you won't know that they don't work because the only thing that's wrong is that a string now doesn't have the value that you expect it to have. So this can fix that. So that's that. We're just going to do that. That gives the name of the activity something. And then what's going on here? And I think it's just warning that it could be null because the source could be null. We're going to ignore that. And then we have these other 2 tasks, and I think we can just add things there. But first, let's run this and see what we get. Because now that we've done this, we should actually see some results. If I do .NET run, we don't. Oh no, what have I done? I don't know. Interesting. Okay. Maybe I've changed too much. Because we do some work, step into this, just to make sure I have this correct. Throw that in there. That shouldn't change anything. I think it's even asking us to refactor that out. That shouldn't change anything. I'm just doing that just to double check. It does change things. Okay, well, that's something for me to go and learn about later, I guess. Interesting. Okay. That's new. Cool. I don't know what to say. There we go. I think this will go back to the same thing, and now it works. Did I just not build? Is that what happened here? Or does it have to be quoted? Let me just double check because I'm super confused and just want to make sure I actually understand what's going on. So we're going to rebuild this. and then .NET run. And I should still see the trace. There we go. Okay. I don't know what was going on, but there we go. So this is the trace that we just ran. And you can see a bunch of the things that we have been adding over the course of this in this trace. So we have our source name, which is coming from our activity source. It's only used once, which to me means one of those isn't used. I think we probably are getting it from this source name and not from this resource, but we can test that by just changing them and using two different values. Then we also have the display name, which is do some work. That's the name of the activity that we just invoked. And then we can see the kind of activity it was. So this is an internal activity happening inside of an application. We have the start time of when this task started and how long it took. So it took 1 second and 500 milliseconds. I think I'm reading that right. So that's all of that. And that makes sense because that's how long we told this to take. We told it to wait a second and then wait half a second. And it almost did that. So that's perfect. But now we want to actually dive deeper because this is just the top level of what we're actually doing. All we've seen is how long did this whole thing take? And that's not the interesting part. What we want to see is how long did each of these steps take? Because that's actually going to tell us what is the problem inside of these steps. Because if I see my task is taking 1.5 seconds to complete, I want to figure out what on the critical path is causing this to slow down the most. Where should I focus my time to improve the performance of this function? And I can't do that without more information because all I know from now is that I need to trace the entire call stack of whatever this is. And in this case, it's 2 functions and they're 1 line. So there's not too much work to do. But a lot of the times that isn't what your code looks like. A lot of the times it's thousands of lines or maybe tens of thousands of lines of code going across all sorts of different classes and doing all sorts of different stuff. And typically not with like a linear call path. So this gives you a way to kind of figure out how do you target and focus your time so you can figure out what to fix. So let's go and do that. I think what we can do, I'm not going to look at the thing here. We're just going to start building on this, is we're going to just add more activities. And so we're just going to do this. And add our steps. And we're going to do the other one too, so step 2. There we go. And so now we have both of those added as well. So I should be able to now run this again. And we should see 3 different responses come across, showing what's happening. And again, those warnings are coming because I am using, I'm referring to this source, which could technically be null somewhere in here, because it's not guaranteed that it's going to be invoked or initialized before we call one of these functions. I could move this above that and it would cause problems. So that's why we're getting those warnings. But if we look back here, now we have a whole bunch of things. So we now have 3 different activities, the 3 activities we created, because we called the one, then the other, and then the other. And we should be able to see a relationship between these. So let's see. We have step 1 here, step 2 there, and then do some work finishes at the end. And you can see, this is really hard to tell, but the do some work task started like 100th of a millisecond before step 1 did. It started just before, and then the other task started. And all that's doing is saying this one started first, took 1.5 seconds, but then step 1, is this the first one that completed? Yeah, step 1 took 500 milliseconds, and step 2 took 1 second. And so you can look at those and also see associations. So we have trace IDs, which is going to actually relate a trace across whatever call we did. And since all of these are the same thing, they should all have the same trace ID. we should be able to recreate this and do some other work. So like bar and 42, I guess. So if we do this, I should be able to run this again. Now we have 6 traces going, but they should have different IDs if I'm understanding this correctly. So this is a 6B9, and then this is B5E, which those don't matter like just as letters and numbers. They're just a hash, but they're different. So you actually know which ones are associated with which other things. This gives you a way to kind of identify the traces that matter. So that's distributed tracing. We can now see how our application is actually invoking things and where time is being spent throughout the application. We can also see what invocations invoke other things, because we can see from here, what is the, there we go, a parent. So we can see from here, the parent of this is 067. So we should be able to look for something with an ID of 067. And here we go. So this one has a span ID of 067. And that's the do some work task. So we can actually trace this all the way back up to what invoked this. And that lets you build a graph over this entire call stack. So you can recreate what ended up getting called. So that's that. Let's go and see if I have missed anything. Let's see, tags. That could be useful. We haven't done those. So let's go and add some tags, I guess. I don't know what this is going to do, but we're going to find out. So let's do activity dot add tag. And we're going to give it a key. So we'll just do, can I do this? Name of foo. And we can just provide foo here. And so again, this is just doing this so that we don't have strings hard-coded into our application. Makes our renaming and things a little bit easier. So we can do this and swap it out there. And so I believe this is just metadata that we're including inside of these traces. And so I'm going to remove this second invocation just because it's just going to take longer. And so to avoid waiting all that extra time, let's just run this. Now we should see a trace with some extra metadata attached to it. So we can actually tell what was sent to this thing. So keep in mind here, you don't want to include things like PII or stuff like that, because then you're going to have that inside of your trace. You probably don't want that logged. But if you're trying to just keep track of specific numbers or certain things that will make debugging this easier, this gives you a way to actually track that. So you can actually figure out what is actually going on. So in this case, we sent over foo and bar with our parameters. So now we know with this trace, these were the things that were sent with this. We know how to track that back. And so if I ever need to recreate that, if this causes, if this specific call with those specific arguments causes my server to 500 error and crash, I can go back and bring that into a dev environment and start testing it. We can actually look at what's going on here. How can I figure out how to use this to solve the problem? That's what that is. And I think, am I missing any other fun things? We have setting tags. So the activity could be null. So when would that happen? So that should quickly talk about that. When we were adding this add tag, we used a null coalescing operator. I want to say that's what that's called. But the way it is it's a question mark period. And so what this is doing is saying if the left-hand side is null, stop execution. Don't do the right-hand side if the left-hand side is null. Otherwise, keep going. So this is really a handy way to check for nulls, because otherwise you have to do something like if activity is not null, and do this. And if you have like 3 of those chained together, that can get really long, whereas you could just write A question, B question, and just keep going. This is just throwing things in, C, and so forth. And so you can do something like this, and it saves you a lot of time rather than embedding a bunch of those null checks together. There's some things that this doesn't cover, but most of the time I found that it will replace those null checks in a way that's a little bit easier to read and nicer. So that's what that is doing. I want to check, because it said this could be null, if it had active listeners. Okay. So it'll be null if there's no active listeners. How would we create that? So I think I'm going to do this because those can be null. Let's remove our exporter and maybe just get rid of the entire trace provider if this doesn't work. But I'm curious how we can actually cause this to break. Mostly because if that happens in my code, I want to be able to figure out how to fix it. And so figuring out how to break it will be useful. Job's done. So we remove the exporter so we don't get any output anymore. There's nothing here. So we don't see any results anymore because I turned that off. I turned off the exporter. So we didn't get a null pointer error though. So let's go and be more extreme. And there we go. Just get rid of all of that. So I think this should be enough to break this. If not, we can do that later. Yeah, there we go. All right. So this is why you have that null check, just to make sure this situation doesn't happen. If you don't have anything listening for these events to actually register and handle this, you'll want to do this. The reason that's important is because these two things could happen in different places. So if you're writing something, maybe you are a platform developer, or you're building a library that is going to be used across your services. These do some work functions could be your library. So this could be what you're actually shipping and providing over NuGet or whatever to people to use in your library. And then up here, we have a tracing provider that's actually configuring our exporter and figuring out how does this team want to actually handle those traces that you're generating. In this case, we're saying we want to handle them with a console exporter, but maybe somebody else consuming your library wants to send them somewhere else. So in this case, all of this part could be a separate application. It could be a web service or something like that. So the advantage of doing that is that you have to configure this. The downside, the reason you want this is if you don't have these question marks here to null check that activity is configured, your library won't work unless everybody that uses it has telemetry configured. And that's probably not what you want. I mean, it might be ideal that they do, but you'd be forcing that because otherwise you'd get a null error. So that's what that's for. This just allows it to be compatible if you disable or turn off telemetry for whatever reason. So that's that. Let's go and find other things. I think we've worked through most of the instrumentation. And then we can add events. So events seem like they're parts of stuff that can be attached to this. So we can actually attach events into our execution. Let's go and see what that does. I'm curious how that will end up looking. So in this case, we add our tags, we do our first step, and then we want a activity. We want to add an event that is a new activity event. I don't know. Perfect. Name. So we can give this a name of halfway done. This probably isn't a particularly useful event because it doesn't actually tell you what it did. So it looks like we do actually need to construct that activity event like that. It doesn't look like you can just give it a string. So that's going to give us a way to actually tell like where we are in this code, which could be kind of helpful for stepping through a longer function. Think of like those print line statements that you stick into your code of like console. Oops. Made it here. When you're like personally debugging on your own machine and you don't really want to start a debugger, so you write this instead. This seems like a way to do that more formally in a way that's more documented, will actually trace a little bit more for you. So that's what's going on there. Let's actually run this and see what we get with that event. I imagine the event will get tied to what we just created. So when we're running this activity, we'll get a event. Interesting. Okay. I don't know what I expected, but this is interesting. So this is our event. I don't know if that's too small, but there we go. So we get this. It has a date time with an offset. So it looks like GMT time. And then has the time that it completed. This is interesting because the time here is the same time as here with less precision and doesn't have the same time zone. So that's interesting. I wonder if there's a way to configure that. But this seems to give you kind of a general overview of like, this thing happened. I'm not sure how I'd use these. I think I'd have to play with these a little bit more to figure out where they fit into my code. But that's what these end up looking like. And you can actually see the events that got triggered inside of your activity, which is maybe the more useful part of this, rather than the time. That could be useful too. But just seeing what actually happened inside of your function could be useful for, especially for longer methods where you're trying to figure out how far through this you actually got. So there's that. And then I think we have baggage, or is that next? Statuses. Set tags. Okay, so this seems like a OpenTelemetry specific thing, so we should probably take a quick look at this. It looks like OpenTelemetry supports things like statuses, which will give you a way to actually report errors in your code. So if something went wrong, you can either set it to an error or say it's okay. It looks like these are like custom things. So I'm kind of curious if there's a way to do like other information. But in this case, it looks like they're prefaced with OTel or OpenTelemetry something. And then it has a status code. In this case, it looks like the options are error or okay. I don't know if there is a constant or something that you could use in place of these strings. I would probably, if I was going to adopt this, would probably end up doing that just to avoid misspelling something and trying to handle it inside of my code and then it not working. So that's that. And then it also looked like there was a status description. Everything is fine. Or everything is awesome. There we go. All right, cool. And I think, yeah, status description. And then you can use that to kind of give more information. Since this is something in OpenTelemetry, while it might not seem that useful here, and probably is not going to print out anything really particularly special when we actually run this, because it seems like it's a standardized thing, other tools might make that more useful to you. So actually be able to show you like a red line in a graph across your architecture, something like that. Whereas here, I imagine we're just going to get something. Why is it taking so long? That's not supposed to happen. There we go. All right. Okay. So yeah, it looks like we get a status code and an activity status description. That's not what we called these. So even in this console description, it looks like it's automatically replacing these with something else, and kind of giving us a little bit more information here and adding a little bit more rich description to what these are. I would anticipate other tools to also do that and provide you with more information in a richer experience depending on this. So that could be useful, especially if you're like catching exceptions and you want to make sure this is where the error happened. You'll be able to actually track that because it'll be tagged to the activity that caused that. One thing I do want to check is, does that bubble up? So we're working at the top level here, at the very top of our invocation. What if we move that into something more internal? And so let's say inside of activity 2, we have everything is not awesome. So let's say we break things here. Will that also show up in the broader activity, or will it just be tagged in that one and you'll have to kind of figure that out in your tooling? That would be useful to know. So let's try this and see what we get. And then I think we're kind of running slowly out of time. I would really appreciate it. There's a survey link in chat. So if you want to go and fill that out, that tells me if I'm doing a good job, if you like what we're doing and you want to see more of it. That's how you can let us know. Yeah. See, here we go. No, it does not bubble up. So this this activity no longer has the error or everything is not awesome. So it's just the activity that has this. But again, you do have links to the parent. So this one links to this one. And you can see this is the top level activity because there is no parent. So that's how you would distinguish those. So you can tell this is a top level function because it doesn't have parent. So there's that. And I think that's mostly it. This is just talking about adding extra activities so you can get more information. And then it looks like looking at things like exporting it to Zipkin, which we didn't quite get to. But if this is something that is interested, Zipkin and also Jaeger are two options for actually viewing these distributed tracing outputs. So once you've generated this whole thing, how do you go and see it? Because the console is great, but I don't want to look at a console and find that in all of my logs when I already am logging a whole bunch of stuff. I don't want to go and search for even more logs. So how do I get that into a nice UI? That could be something that we maybe look at later and try to figure out more about. So if this is something you want to see, we could probably do an entire episode kind of just setting this up and changing our exporter from a console exporter to something that supports Zipkin or some other open telemetry provider. But yeah, I think that's mostly it. So I will leave this here. If you do want to check this out, the link to kind of get to this documentation is aka.ms/learn.net distributed tracing. And that will take you right here. And so you can use this to go and do all that. Also, if you're interested in learning more about what's coming in other Microsoft tech, we have Microsoft Ignite starting, I believe, next soon, and it's free online. So if you are looking to just learn more things and maybe catch up about what's happening, this is a great way to do that. You can just register online. There's no cost to you, and you'll be able to check out all the sessions that are interesting, whether you're interested in more cloud native stuff or maybe some of our other stuff. So thanks so much for joining us, and hope to see you next week.